Lesson 2, topic solving quadratics, learning target, I can solve a quadratic equation by graphing. First off, a reminder, the x-intercepts, or when y equals 0 of a quadratic function, are the solutions to the related quadratic equation. So the x-intercepts, graphically, they would be seen as where we touch the x-axis. So as you can see here, we do not have a point where the graph touches that x-axis, so that means we just have no solution. Here we have only one point where the graph touches the x-axis, and that's right here at 3, 0. So you can see the x number is 3 and the y number is 0, so when that y equals 0. And then we have this last example where we have 2 points where the graph touches the x-axis, so that's where we have those two solutions, x equals -2 and x equals 2, because it touches at 2, 0 and -2, 0. So to find the solution by graphing, all we have to do is graph the quadratic equation and then find where it touches the x-axis. So the first thing we need to do is make sure our equation is set equal to 0. We did this last unit as well, so if we look at our equation, it says equals 3. So we want to undo that positive 3 with a -3 on both sides. 3 take away 3 is 0. And then we have x squared minus 2x minus 3. We can't combine any of those because none of them are like terms. And now we need to graph the equation. So you guys did this last lesson and we reviewed it before this lesson. So let's try practicing that on our own. First off, you're going to need to find the line of symmetry. Now remember that equation is x equals the opposite of b over 2a. You're going to need to find the vertex. And then you're going to need to make your table. So go ahead and do that work right now. So you find your line of symmetry, your vertex, and then complete that table. And then you can check your work in Edpuzzle. Alright, so when we found the line of symmetry, we should have plugged in the opposite of b, which is -2 over 2 times 1. And then when you type that into your calculator, you should have gotten x equals 1. And then when we put 1 into our equation, we should have gotten 1, -4 for our vertex. And then as you filled in the table and you completed the rest of this, it should have looked like this. If you did not get this correct, I want you to pause the video right now and call me over in class so we can talk about it. So then your x-intercepts are the solutions. So where do we cross the x-axis? We cross right here and right here. You can also see it in the table right here where y equals 0 and right here where y equals 0. So our solutions would be just the x values, so x equals 1 and x equals 3. So that's how you find the solutions by graphing. So now an application of this is the vertical motion model. So that model is just this equation right here, which is h. Now h stands for height, and that height is always in feet, equals -16, so that -16 represents gravity, because everything's, if you throw something in the air, it's going to fall down due to gravity. T squared, now t represents time in seconds. So this equation is going to tell you if you throw a ball in the air, or if you throw a paper airplane, or you toss something, and then it's going to make that parabola shape, how high is it going to go, and how long is it going to be in the air for? So then we have two other variables that we'll have to plug in, which is the initial velocity, so the force behind it. So are you just dropping something, or are you putting some force behind it? And then s is the initial height. Where is it starting off being thrown from? So let's apply this vertical motion model using our example. You throw a lacrosse ball twice using a lacrosse stick. For your first throw, you release the ball at 9 feet above the ground. So that's telling us right here that that's your initial height. How high was the ball when it was released? 9 feet above the ground. and then an initial vertical velocity of 48 feet per second. So that initial vertical velocity of 48 is that v variable right there. So now we're just going to put that all together. We're going to write our equations. We're going to have h equals negative 16t squared plus we replace the v with that initial velocity, which is 48. Keep the t next to it, plus s. So s is that initial height, that 9 feet above the ground. Now for our second throw, we release the ball at 6 feet above the ground. So that is going to be our initial height, that s variable, with an initial vertical velocity of 64 feet per second. So that's that force behind the throw. So we were a little more forceful with that throw. And that's the v variable in the middle. So let's write our equation. We have h equals negative 16t squared plus 48t plus 9. So now once we've written our equations, we are going to use some graphing technology in order to graph these lines. But before we use Desmos to graph our lines, we want to think about what our axes represent. So our x and y axis. So because we're not using the variables x and y at this time, because we have h equals negative 16x squared plus v, not even x squared, we're using t, see? We're so used to using that x. So we have to think about what would be replacing the y and what's replacing the x. So we usually write y equals, so the h is replacing the y, so it's really our y-axis is representing h, which is representing height. And then we would have a x squared, so that t is replacing the x. So our x-axis is really t for time. So we want to be thinking about that because that does help our interpretation of our graph. So now when we get to Desmos, we want to label our axes. So we're going to hit this wrench graph setting. We're going to go to our x-axis, add a label, and that is time. And I'm even going to go a little step further, and in parentheses, I'm going to put seconds. So remember that that represents seconds. And my y-axis is height, and in parentheses, I'm going to put feet. So remember it's height in feet. So then on this left side, we're going to type in our two equations. We have h equals negative 16t squared plus we had 48t plus 9, press enter, and then type in the next equation, and we had 64 and 6. So now you can see your graph here, and you can mess around with the zoom in, zoom out settings. You can even change some things in here, makes it a little bit easier to see. And once you get a good viewpoint, you can drag the points around. You can click on any point, so you can see our vertex here is 270. So at 2 seconds, after 2 seconds of being thrown, the lacrosse ball was 70 feet in the air. And then here we can see after 1.5 seconds after being thrown, this ball was 45 feet in the air. So that's what those coordinate points mean. So different applications require different questions. So our question for this lesson is, if no one catches either throw, for which throw is the ball in the air longer? So the red one is your first throw, your green one is in the second throw. I want you to figure out, is it the first throw or the second throw that's in the air longer, and tell me why.